Good morning, students. Myself, Raghav Raju. This video lecture content explores our knowledge on applications of thin linear wire antenna, folded dipole. Hi, students. This video lecture focuses on folded dipole. Previous video lecture shows how half-wave dipole act as applications of half-wave dipole as thin linear antennas. So this video lecture focus on application of thin linear antenna half-wave dipole as folded dipole. You are watching the figure for folded dipole. So this is one metallic rod. This is metallic rod taken here. So we are bending two metallic rods in such a way that their end tips are applied to some energy sources, some applied as feed. Therefore, maximum radiation of folded dipole is aligned along major beam, or simply called it as main beam. So this major beam or main beam is focused along the main body, simply called it as main lobe direction. You are watching the folded dipole figure where two radii of half-wave dipoles are positioned along the half-wave dipole. So this half-wave dipole focus on two radii of our normal regular dipole. So therefore, two radius of folded dipole are positioned along the interval. So all dimensions are indicated here. So these dimensions are indicated by the diameter. First pole, those pole connected to primary end, that is having diameter d1. Those pole having opposite to the energy source, that is positioned as d2. This d1 and d2 are configured according to millimeter dimensions. So we are taking aluminum as material to make this prior radiation in the major lobe direction. A comma B, A and B are their cross-sectional view of folded dipole. Both ends are measured. Both ends are measured along the thin dipole such that their dimensions are located along the two radii of your regular dipole. So A comma B. So A and B are their cross-sectional view. of their particular folded dipole. So the length of this folded dipole, are measured as this much lambda by 2. So at the opposite end, the center of folded dipole at the opposite end, center of this folded dipole A and B is positioned at midpoint C. So A and B, so A and B, their position regular increments are A comma B. And C is the midpath, which is called the virtual ground connection. So A comma B are their virtual ground connection and C is their opposite end. So A and B, their cross section, their dimensions are located from center to center lambda by 2. The D1 and D2 are their particular diameter of the folded dipole. So their two ends are located. Their two ends located at the center of their particular end. So therefore, their ends are properly biased. Their ends are properly biased to the respective ends. Mm, So this is the radiation pattern. So this is the radiation pattern. So this is the point A comma B are two virtual points. So these are the 2 points on the where the dimensions are shrinked lambda by 2. So as the phenomena of this lambda by 2, as the phenomena of this lambda by 2 that is positioned along the main beam. So this is the major radiation. So this is the point along the radiation. So this is the radiation pattern. So this is the radiation pattern obtained along the. So this is the main lobe. It's called main lobe. And this is the main lobe area. So total current. Suppose this primary feed generated current I. Total current splits to 50-50. I by 2, I by 2, from bottom and top. This is also multi dipole. So this is the multi. So this is the multi-input, multi-level voltage, multi-level voltage. So this voltage is feed to their corresponding values I1 and I1. So when primary feed radiated towards the sun, while this the layer, while this is the layer, lambda by 2, and this is also the lambda by 2. This lambda by 2 is arising from here. So this is the voltage V. From voltage V, the total current is fed to this point I1. So I1 and I2, so this is the majority of these currents that are distributed. So in previous two, so I equal to I by 2, I by 2, whereas here total partitions, 3 partitions, so I by 3, I by 3, I by 3. So your radiation voltage. So this voltage